Project 3.2.3, CHUMP, ALU by Atticus Stipulati. This is the third video in a series documenting the creation of an ACES CHUMP, which stands for Cheap, Homebrew, Understandable, Minimal Processor. The purpose of this project is to create a functioning arithmetic logic unit, ALU for short, a chip capable of performing arithmetic and logical operations through the use of a 74LS181AN chip, along with many other features such as several square LEDs seen in previous CHUMP projects and various dual switches. In the circuit, the ALU acts as that similar to a calculator handling tasks such as addition and subtraction based off of its various inputs. Moreover, the 74LS181 ALU chip is also able to execute logic operations including comparisons, greater than, less than, or equal to, etc., and bitwise operations, and, or, XOR, and not, etc. The ALU functions by receiving input data, also known as operands, from either registers of memory and processing it according to the specific operation declared, ending it by sending the outputs as the result back to a register or memory. The 74LS181 ALU chip includes several key pins that allow it to handle various arithmetic and logical operations. Pins 1, 2, and 18 through 23 serve as input lines for two 4-bit datasets, A0 to A3 and B0 to B3, which are primary operands. These inputs connect to individual dip switches to easily toggle between high and low voltages. Standard voltage, 4.75 volts to 5.25 volts, and ground connections are found on pins 8 and 16. Pins 3 through 6, labeled S0 through S3, act as function selectors, allowing the user to choose among 16 different operations, such as addition, subtraction, and, or, and XOR. Pin 8, known as the mode or M pin, determines if the ALU will operate in arithmetic low or logic high mode. The carry-in pin, pin 7, allows the carry bit from a previous calculation to feed into the current operation, impacting addition or subtraction processes. Pin 16 serves as the carry out pin, or CN+4, which outputs the carry bit generated by arithmetic operations and can act as an overflow indicator. Pin 14, labeled A equal B, outputs a signal when all bits of A and B are equal. This pin is an open collector output and needs a 2.2 k ohm resistor with 5 volts to function correctly. Finally, pins 9 through 11 and 13, labeled F0 through F3, provide the operation result, outputting the ALU's computed arithmetic or logical values based on inputs A and B. The table included describes how changing the S0 through S3 pins input will shift what operation the ALU will perform. Logic is referring to when pin M, also known as mode control pin, is high, while arithmetic portion of the table is referring to when the pin M is low and pin CN, also known as the carry in pin, is high. For example, in this video displayed, the S inputs are high, low, low, high, where in the logic operation the outputs is not A, XOR, not B. However, the arithmetic operation is A plus B. Looking at the inputs displayed on the bar graph, we can see that the highest bit of the A input and the second and third bit of the B input are positive. As a result, the output is the A and B input added together. Thank you for taking the time to watch my video on the RSGC CHUMP ALU.